So this is our second sample question that we have to get through. So again, the directions don't really tell us what to do. Like the first one, all we had to do was factor out the common polynomial. Here, again, the directions still say factor completely. So as soon as you see factor completely, let's always start with our GCF, A, B, C, D. So A, do we have any matching set of parentheses? No. B, do we have the same letter in every term? This is term 1, this is term 2, this is term 3. Ooh, they all have the letter P. When they all have the same letter, we told you want to grab the smallest exponent. So 8 versus 5 versus 3. So we know we have a GCF for P, and we know it's going to be P cubed. Now, just because you have a GCF for part B, you still got to check part C and part D. So let's see, do we have anything else? Do we have a common number factor? When you see that they're all even numbers, that's a clue that you definitely have a GCF. Now, I'm not saying that that means that your GCF is definitely a 2, but that just means, yes, you have a common number. So let's do a tree diagram for each of these coefficients. So 18, again, it doesn't matter where you start off with. You might do 2 times 9, and then 9 is 3 and 3. What you're trying to do is get all prime numbers. 24, maybe we saw 4 times 6 before, and that means 2 and 2, and 6 is 2 and 3. And then for 12, maybe that was that 2 and 6 you saw, and then 6 is 2 and 3. So when you look at them, especially when there's a lot of circles, you might want to put them in order. 18 was 2, 3, and a 3. 24, that was 2, 2, 2, and a 3. And then 12, that was 2, 2, 3. If this helps you, feel free to do this. And then circle something that they all have in common. So they all have 1, 2 in common. Do they all have a second 2 in common? No. You can see these two do, but it has to be something that all have in common. But you can see they all have a 3 in common. So let's go and circle that 3. So then you know your GCF for numbers is 2s and 3s, but multiply them. Don't keep them separate. So you know 2 times 3. Our GCF for numbers is 6. So we did A, parentheses, no matching. We did B, they had the same letter, so we grabbed the smallest exponent. We did C, found out that they all had 2s and 3s to make our GCF 6. And D, does it start with a negative? Look at your leading coefficient. Notice here it's 18, no negative sign, so there is no negative part D that we have to worry about. Just because this sign has negative, you have to look at your leading sign. Since this is positive, we don't have to worry about taking out a negative as part of our GCF. So once we found out our GCF is the 6p cubed, you know you need your leftovers. To get our leftovers, you're going to divide each and every term by your GCF. Divide this by 6p cubed here, and 6p cubed here. So when you divide out, 18 divided by 6 should always divide out evenly. Should never be a decimal, should not be a fraction. If you took out the correct GCF, they will always divide out evenly. P to the 8th, P to the 3rd, remember, you always will have more P's on top or a tie. So here, P to the 5th. Negative 24 divided by 6, you know that's going to be a negative 4. And then 2 P's, or 5 P's versus 3 P's, you have 2 more on top, P squared. And finally, 12 divided by 6, we're going to get a 2. P cubed, ooh, there's our tie. Remember, if there's a tie, they're all gone. This term will not have any P's. If you took this times this, times this, you'll get your original answer. So that's your second question.